Hi friends, myself Sanjay Gaikwad. I am working as assistant professor and head of the Department of Physics, Mahatma Phule ASC College, Panvel. Today we are going to discuss on the radioactivity phenomena. In modern physics paper number 2 of your 5BC syllabus, the next unit, that is radioactivity, paper number 1, unit number 1. Radioactivity is the first chapter. Generally what happens when we are considering about the atom? This is symbol of the radioactive material. Generally in the atom what happens? The electrons are there. Electrons are revolving around the nucleus, and in the nucleus what are the constituents of the nucleus, which is well known as the nucleons? That is a proton and neutron. Proton and neutron. Generally in the radioactivity phenomena, it is related to the nucleus. Just like a chemical reaction, there are nuclear reactions are there. Same way, when the nucleus is unstable, then the radioactivity phenomena takes place. Why nucleus is unstable? Generally, what happens when we are going to the higher atomic level, then there is a ratio of the proton to neutron, that is neutron to proton, is greater than 1. Means what happens? The number of neutrons increases as compared to the number of proton. For example, you are considering that U-235. You know that U-35, 92. Uranium is one of the most famous radioactive element, and when we are considering that the atomic number is 92 and atomic mass number is the 235, generally we are considering this as a Z and this as a. Okay, this Z represents the number of protons. Remember that this represents the number of protons, and when we are considering that for radioactive material, there is what happened? This is the Z, nothing but the number of proton, and this U-235 is nothing but U-235 is represent that sum of the number of proton and neutron. It represents the atomic mass number and atomic number and atomic mass number, and we are considering that the 235 is nothing but N plus P. Okay, N plus P. Then what is the number of proton? What is the number of neutron? When we are considering that here the proton is 92, we are considering the 92, 3. When we are considering subtraction, we have got that 143. Means here the neutron number is 143. And what is the number of proton? Proton number is 92. Means when we are going to the higher atomic number, nucleus is unstable due to the heavy increasing the number of the neutrons. And to balance the nucleus or to retain the stable the nucleus, nuclear reaction takes place, and sometimes radioactive phenomena occurs. Generally, radioactive phenomena is spontaneous, natural phenomena, but nowadays we are turns to the artificial radioactivity also. Generally, initially it is a natural phenomena, but when we understand the phenomena, mechanics behind the radioactivity, the reasoning behind that, or the physics behind this radioactive material, we come to the artificial radioactivity. And radioactivity is the one of the major discovery of the physics in which the wide application is there. Generally, we know that in nucleus this radioactivity phenomenon takes place, but the use of the radioactive elements for the human being, medical purpose, to preserve the foods, like that, wide applications are there to study the many things of the physics. So, in the introduction, what is the radioactivity? Radioactivity is one of the spontaneous emission of the radiation. This word is very important. Spontaneous. Spontaneous means it is a natural phenomenon. What happens when nucleus is unstable? It radiates some radioactive materials like alpha, beta, gamma, and this phenomena is known as the radioactivity. So, first, it is also we call it as a reversible self-disintegrating process or spontaneous process. Okay, first of all, when backward in 1896, he found out or discovered the uranium element. Some of the Marie Curie and Pierre Curie discovered the thorium, polonium, radium. And for the discovery of the polonium in the chemistry, the Marie Curie and Pierre Curie got the Nobel Prize. Like this, these are the various phenomena there. And some side Rutherford discovered the alpha and beta gamma beta rays, and Willard in 1909 find out the or discovered the gamma rays. Generally, we consider that only alpha, beta, gamma emission means radioactivity. No, but there are the various phenomena there, and we study about the natural phenomena, that is natural radioactivity and artificial radioactivity. Okay. On the basis of application we study. This is one of the famous experiment, you know that. When the radioactive element is kept in a lead box, and when we are applying the electric field and magnetic field, we find out there are the three different types of elements are emitted from the radioactive material. First is the alpha. What this represent? It easily diverted towards the negative plate. It easily diverted towards the negative plate. Therefore, we consider the alpha particle is positive charge. Alpha particle is positive charge, and it is diverted easily, means it is a heavy element as compared to this beta particle. Beta particle deflected towards the positive charge, means beta is negative charge, and therefore we consider this is the negative charge. It is very low divert as compared to alpha particle, means it is a light particle as compared to alpha particle. Third thing is a gamma particle, which is not diverted by the any electric plate, that is positive or negative. Therefore, we consider that gamma is the electrically neutral particle. And on the basis of that, we study various phenomena like their masses, their velocity, their ionization power, penetration power. Different phenomena we study about the alpha, beta, gamma particle. Also, we study about the natural radioactivity and artificial radioactivity in the next lecture. So remember that in alpha, beta, gamma, we study about the three things, that is the what is the penetrating power. Generally, the alpha particle, beta particle and gamma particle, gamma has the highest penetrating power because it is a high velocity particle. And second thing, or considering the ionization power, the alpha particle is the heavy particle. It interacts with the many gaseous particle, and therefore we consider that alpha has the more ionizing power. Means ionization of the gas particle takes place by the alpha is more as compared to the beta particle, and beta particle has the high penetration power is greater than the alpha and lower than the gamma particle. Like that way, we are discussing on the various phenomena related to the alpha, beta, gamma, and what happened in the nuclear reaction. We also discuss with the next topic. Thank you.